Good morning. Next is cyclic structures of monosaccharides. Cyclic structures of monosaccharides. Hemiacetal formation. Hemiacetal formation. So, cyclic structures of monosaccharides, that is hemiacetal formation. We know that when an aldehyde react with an alcohol, will form an addition product called hemiacetal. Similarly, when a ketone react with alcohol, will give an addition product hemiketone. So, when an aldehyde RCHO react with an alcohol R dot OH, we know that this is a RO minus and H plus will attack on the positively charged carbonyl carbon, and this will be shifted to here. This reaction already we discussed. So what we get? We get an addition product like this CH. Here it is. What will come here? OR dash, O R dash, and here it is O minus, and this H plus will join with this O minus, and you get OH. This is known as hemiacetal. So when an aldehyde react with an alcohol OR minus, this part, that means R dot O, this part will attack on carbon, so you are getting OR dash, and H is joining with the OH. This product is known as hemiacetal. Similarly, if you take a ketone RC double bond OR, here R will come, then it is known as hemiketone. Now, in the case of monosaccharides, we know that monosaccharides are containing an aldehyde group or a keto group, aldose or ketos, an aldehyde group or a keto group with many OH groups, So what will happen? There is a possibility of intramolecular interaction between aldehyde group and alcohol group, or keto group and alcohol group in the same molecule, which will result in the formation of a hemiacetal. That means that hemiacetal will result in the formation of a cyclic structures for monosaccharides. So look at it here. So same reaction can occur in monosaccharides, because in monosaccharides we know that there is an aldehyde group or a keto group and many OH groups. So similar type of reaction can be occurred in monosaccharides, which will result in the formation of a cyclic structure. So look at it here, how the cyclic structures are forming in monosaccharides. Let us take glucose. Okay, glucose, that means CH2OH, CHOH, COH, H, CHOH, CHOH, and CH2OH. So here it is CHO, CHO, CHOH, COHH, CHOH, CHOH, and CH2OH. This is D-glucose. Okay. So this is the open structure of glucose. What type of structure is this one? Open structure. This structure is called open structure. Okay, the structure is called open structure. Now look at it here. This is carbon number 1, 2, 3, 4, 5, 6. Now, this CHO can be written as, listen to me very carefully. This is our D-glucose. This is our open structure. In this open structure, CHO group can be written as, how will you write CHO group? The actual structure is C double bond O, and here it is H. You can write like this. This is how CHO group can be written like this. Now look at it here. The OH group present on the fifth carbon. Which carbon? Fifth carbon. The OH group present on the fifth carbon will interact with the carbonyl carbon. Will interact with the carbonyl carbon. That means the OH group present on the fifth carbon. That means this OH group, this lone pair of electron will attack on this partially positively charged carbon. Then what will happen? This bond will be shifted to here. This is the actual mechanism of the attack of alcohol on the carbonyl group. Okay. So this lone pair of electron will attack on this carbon. This bond will be shifted to oxygen. So what we get? We get a structure like this. Listen to me very carefully. C, and here it is O. When this is shifted to here, it will become CO minus, and here it is H. And look at it here, CH and OH, and here it is OH, and here it is H, CH, OH, and here it is C, and here it is H. Since this pair of electron, lone pair electron is attacking on this carbon, I can write this one as, see, look at it here. Here it is, I can write this is OH, and this pair of electron, this is attacking on this carbon, okay, and it will be like this, and then this is shifting to here. Since this pair of electron is attacking that carbon, this oxygen is getting a OH, can be written as OH. Now oxygen is having 3 bonds. Of course, oxygen will get a positive charge because this pair of electron is attacking on this carbon, and you get a structure like this, and here it is CH2OH, CH2OH. Clear? So look at it here. The OH group on the fifth carbon, this pair of OH group, this pair of lone pair electron is attacking on this carbon. So I am writing that bond like this. Okay, that means this OH group is attacking, and you are making a structure like this, and this bond is shifting to. Now in the next step, what will happen? The next stage, you can see that this bond is coming back to oxygen. Then what will happen? This H plus is removed. That means minus H plus is removed from this bond is shifting to here, minus H plus. That H plus will join with this O minus. That means minus H plus H plus means it will come to oxygen. So in the next step, what I can write? Okay, look at it here. The next structure can be written like this. I am writing from there to here. Okay, how it will become? CH, here it will become, since this hydrogen is removed from here and is coming to oxygen, this will become OH, and the rest is the COH and COH, H, CH, OH, CH, and here it is CH2OH, and look at it here. Now here it is oxygen, and here it is you get a structure like this. Okay, so in order to gain the stability, what will happen? This bond is coming back to oxygen, then this positive charge is removed. Then here the H plus is removed, that means minus H plus, that H plus is attaching to oxygen. So you get this structure. Now we can see that this structure is known as alpha D glucose. This structure is known as alpha D glucose, and look at it here. Another ring, this is what is called cyclic structure. This is cyclic structure. Now the same thing can be, this structure can be represented in the form of a ring. Okay, in the form of a ring. So look at it here, this is known as alpha D glucose, and the same thing can be shown in the form of, can be showed in the form of a ring. So look at it here. That means in the ring means the ring is consisting of 1, 2, 3, 4, 5 carbon and an oxygen. That means this is the ring. This is the ring. 5 carbon and oxygen. That means the ring consisting of 5 carbon and an oxygen means the ring will be like this. Okay, first you write the ring like this. Because now you look at it here, 1, 2, 3, 4, 5 carbon and an oxygen. 1, 2, 3, 4, 5 means this same ring structure can be shown like this. Now this is our oxygen. Now we come to here. This is the first carbon. First carbon. So that means this is the first carbon. And this carbon, H is left side. That means here you can see that here it is H and OH is down. Okay. And the next carbon, this is the second carbon. That means this is the second carbon. Here also left side is H. That means H is up and OH is down. And here you can see that OH is this side. That means OH. And here it is H. And in the next carbon, H is up and OH down. And in this last carbon, this CH2OH, this is up, CH2, here it is CH2OH and here it is H. Same thing, this can be shown like this. This type of structure is known as a pyranose structure. What is this one? Pyranose structure. So this is alpha D glucose, that, or this one is alpha D glucose, or you can call it as alpha D glucopyranose. Alpha D glucopyranose. Alpha D glucopyranose. This is pyranose structure, or simply you can call it as alpha D glucose. Okay. So once again I repeat, this is the cyclic structure, this is the cyclic structure, and you can see that there are 5 carbon atoms, 1, 2, 3, 4, 5 carbon atom and an oxygen in the ring. Okay, 5 carbon atom and oxygen in the ring. Oxygen is here, and this is the first carbon. First carbon, this side, this side, left hand side must come up. That means H is here and OH down. Second carbon, H up, OH down. Third carbon, OH up and H down. Fourth carbon, this H up, OH down, and here it is. This always, this is up, CH2OH up and H is down. If you represent like this, then it is known as pyranose structure. So this is alpha D glucopyranose. Now look at it here. So this is alpha D glucose. What is this one? Alpha D glucose. Alpha D glucose. And now you can see that. This OH. If you write this OH left hand side and H is right side, you get another structure. That means you see OH, H, and here it is CH, OH, and COH, H, and here it is CH, OH. The rest is CH, here it is CH2OH, and here it is our oxygen. Okay, so what is the difference between these two structures? You can see that here OH is right hand side and H is left. And in this structure you can see that OH is coming in the left hand side, H is in the right hand side. This is alpha D glucose, and this one is known as beta D glucose. Beta D glucose. Beta D glucose. Now look at here. Let us draw the pyranose structure for beta D glucose. Let us draw the pyranose structure for beta D glucose. So look at here, same pyranose structure. Okay, so you can see that same way you can show the pyranose structure for beta D glucose. Again, this is our oxygen. You come to the first carbon. First carbon is, this is first carbon, and you can see that now OH is this side. So the OH will come up. Okay, left hand side, so OH is coming up and H down, and this is the only difference between alpha D glucose and beta D glucose. Okay, the rest is as it is. Second carbon C, here it is H, and here it is OH. Third carbon OH up, H is down. Fourth carbon H up, OH down, and fifth carbon, you look at it here. CH2OH is end. This is end side only, CH2OH up and H. What is this one? This is also beta D glucose. But when you show beta D glucose like this, this is known as a beta D pyranose. Beta D glucopyranose. Beta D glucopyranose. So when you show the structure like this, what is it? It is known as a pyranose structure. Now, we know that why there is a possibility of forming alpha and beta structure. Okay, look at it here. We start with our open structure. What is D-glucose? D-glucose is CHO, CH, OH, COH, H, CH, OH, CH, OH, CH2OH. Okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. This is our glucose. This is our glucose. Okay, this is our glucose. What glucose? This is not alpha glucose or beta glucose. This is simply D glucose. This is our D glucose. Okay. Now this is open structure. What type of structure is this one? Open structure. In open structure there is no alpha D glucose or beta D glucose. Only D glucose. But when it come to cyclic structure, we get alpha D glucose and beta D glucose. What do you mean by cyclic structure? As we discussed, the fifth carbon. That means CHO group can be written as C double bond O H, and here it is. This is our fifth carbon, the OH group. The lone pair electron present on the OH group on the oxygen will attack here and it will be shifted to here. That means it will change into the cyclic structure. It will change when it will change into the cyclic structure. When it will change into the hemiacetal form. When it will change into the hemiacetal form, we get two structures. What are they? Alpha D glucose and beta D glucose. What is the reason why when it is changing to cyclic structure, it is getting two structures? That means alpha and beta. Now this is open structure. Once again I repeat, this is open structure. In open structure there is no alpha and beta. Only D glucose. Only D glucose. What is the reason? Look at it here. In open structure, this carbonyl carbon, this is our carbonyl carbon, this is our CHO group. In this open structure, the carbonyl carbon, this carbon is not chiral. This is not a chiral carbon, not chiral. Very important, this is not a chiral carbon because you can see that this carbon is double bonded. Double bonded carbon means it is not a chiral, it is a chiral. This is not chiral. This is not a chiral. That first you keep it in mind. In the open structure, the carbonyl carbon is not a chiral carbon. But when it is changing to hemiacetal form, that means this pair of electron is attacking on here and this bond is shifting to here. That means that time this OH is attaching to here and you get a structure like this, COH, EH, and here it is CH, OH, COH, H, CH, OH, and here it is CH, and what is happening here? Here it is O, and here the bond is like this. Okay, and here it is CH2OH. This is our hemiacetal form. When the open structure is changing to hemiacetal form, we can see that the carbonyl carbon is changing to a chiral carbon. This will become chiral. This is very important. Here in the open form, this was not a chiral. This carbon is not chiral. This carbon is not chiral because this carbon has a double bond. It is not a chiral carbon. But when it is changing to hemiacetal formation, when it is changing to a hemiacetal, what is happening to this carbon? This carbon will become chiral. This carbon will become chiral. Look at here, this carbon. One bond is with hydrogen, another bond is with OH, and here this side is third bond is with this part, and here it is with oxygen. That means this carbon is becoming a chiral carbon. So since the carbonyl carbon is changing to a chiral carbon, when it is changing to hemiacetal, the carbonyl carbon is changing to a chiral carbon. Therefore, it will give two structures. What is one is alpha D glucose, and the other one is beta D glucose. What is beta D glucose? When you rotate this carbon, chiral carbon, the OH will come this side and it will go that side, and we get beta D glucose. This is the reason why the cyclic structure is giving two structures, that means alpha D glucose and beta D glucose, because in the open structure the carbonyl carbon is not a chiral carbon, but when it is changing to a cyclic structure, the carbon will change into a chiral carbon. Based on that chiral carbon, we get two structures, alpha form and beta form. Clear? And we get two pyranose structure also, alpha D glucopyranose and beta D glucopyranose. That structure also we can draw. Okay, hope it is clear to you. Now, pyranose structure for fructose. Suppose you are asked to draw the pyranose structure for fructose. Pyranose structure of fructose. Then we know that the open structure of fructose, already we discussed what is the open structure of fructose. CH2OH, CO, C, OH, H, C, H, OH, CH, CH2OH. This is the open structure. What structure is this one? Open structure of D fructose. This is open structure of D fructose. Open structure of D fructose. Okay. Now we know that it will interact the fifth OH group, the carbon OH group present on the fifth carbon, 1, 2, 3, 4, 5, will interact with the carbonyl carbon. Okay, that means the actual structure of fructose, here it is CO means C double bond O. Clear? This is the open structure. Now, as we discussed in the case of glucose, this pair of electron will attack on this carbon and this bond will be shifted to here, and we get a structure like this, C, this C, and here it is O minus this CH2OH. That, okay, C, this will be O minus, and this CH2OH. This CH2OH I am writing here, CH2OH. Okay, no problem. And the rest is C. Here it is OH. Here it is H, C, H. Here it is OH, and here it is C, H. And here you know that this OH, and this carbon. So and what will happen as we discuss OH, and here it will become like this. Oxygen is getting a positive charge, so it will remove this H plus, and that H plus will attach here. Okay, and here it is CH2OH. Clear? As in the case of glucose, nothing. This OH, this pair of electron, the lone pair electron present on this oxygen will attack here on this carbon. This will be shifted to here, O minus. Then this H plus will attach to here. This CH2OH I have written here. So you can show like this. Okay. Now, this structure is known as, now you are getting, when it is changed to hemiketal form, you are getting two structures. What are they? You are getting two isomers. One is alpha form and the other one is beta form. This one is, what is this? Alpha D fructose. Okay. Now look at here. How will you draw the pyranose structure? Pyranose structure of alpha D fructose. Now look at here. In this cyclic form, 1, 2, 3, 4, 5 atom. Okay, this is the ring. This is the ring. Okay, in the ring, 4 carbon atoms and 1 oxygen atom. That means total 5 atoms. 4 carbon atoms, 1, 2, 3, 4, 4 carbon atom, and an oxygen is present in the ring. So I am drawing the ring like this. Look at me carefully. Okay, and okay. So 1, 2, 3, 4 carbon and an oxygen. Clear? Or 4 carbon and an oxygen. I take the first carbon. First carbon is this one, and this one is the second carbon. So in the ring, the second carbon is present. So this is our second carbon. This is our second carbon. In the second carbon, there is one CH2OH. So CH2OH group is left hand side, so it will come up. CH2OH, as in the case here it is OH, and the next carbon here the OH is this side, that means OH is up, H down, and here next carbon here H up, because H is this side, left side, H is up, and OH down, and in the last carbon CH2OH. This is the N part. N part means here it is CH2OH, and here it is H. This is the pyranose structure for alpha D fructose. Pyranose structure for alpha D fructose. Clear? So keep it in mind here, the ring containing only 5 atoms. So this is the ring. Okay, this is the ring. In this ring, 4 carbon and an oxygen. So 4 carbon and oxygen. Okay, the first carbon is out of the ring, so it is CH2OH, and second carbon, this carbon is in the ring. This is second carbon, this is second carbon, third carbon, fourth carbon, fifth carbon, and this is sixth carbon. Okay, this is the pyranose structure for alpha D fructose. Alpha D fructose. Now look at here. Now, based on this chiral carbon, you get one more structure. What is that? The OH is coming left hand side, and CH2OH is going right hand side. Okay, so you get the structure like this. Here it is OH, and here it is CH2OH. So what is this one? This is known as beta D fructose. Beta D fructose. Okay, and how do you draw the pyranose structure for beta D fructose? Again, same way you can draw, very simple. Okay, look at it here. Okay, this is we start with this carbon. So for 1, 2, second carbon. Okay, this is our second carbon, and you can see that in this carbon OH is left hand side, so it will come up, and CH2OH is here, CH2OH. Clear? That is the only difference between alpha and beta. The rest is as it is here. Next carbon, third carbon, here it is OH, and here it is H, here it is this H, and OH is down, and this is N, CH2OH, and here it is H. This is the pyranose structure for beta D fructose. Hope you understand what is pyranose structure. What is the reason to for the formation of two isomers, that means alpha and beta. In the open form, in the open structure, the carbonyl carbon is not chiral, it is achiral, not a chiral center. Carbonyl carbon is not a chiral center, but after the conversion of hemiacetal or hemiketal form, we can see that the carbonyl carbon will become chiral. Based on that chiral carbon, we get two structures, alpha and beta, and based on that structures, we can draw the pyranose structure for two isomers. Okay, thank you.